Assalamu alaikum wa rahmatullah. In this video, I'll solve system of equation, two equations, maybe two linear equation or one linear and one quadratic. Let's start by question number one. I have two equations here. These two equations are simultaneous equation where k is a constant. Show that y is -2. To show y is -2, I have to remove the x terms here. So the first equation, I just take it and multiply it by -2. This equation, just multiplied by -2. So the answer will be -4kx plus 2y is equal to -8. Okay, and just copy the other equation, 4kx plus 3y is equal to -2. By adding the two equations, the x is cancelled, so you have 5y is equal to -10, so y is equal to -2. So the value of y is -2. Find an expression for x. After knowing the value of y, you can substitute in one of the equation, the easiest one you can substitute. So if you go to the first equation, you have 2kx minus the y is -2. Okay, is equal to 4. So this is really plus 2. So 2kx is equal to 4 minus 2 is 2 divided by, I want to find the expression for x in terms of k. So divided by 2k each side. Okay, so I have x is equal to 1 over k. And this is the value of x in terms of k. Okay, next question here. Question number 2, solve simultaneous equation. This one is a linear equation, okay? This one is linear, and this is quadratic or second degree equation. In this type of question, it's better to substitute from the linear into quadratic. I mean, you can make x subject from the first equation, equation number 1, x is equal to 3 minus 2y. And the other equation, equation number 2, x squared minus 4y squared is equal to -33. You can substitute now from the first equation into second equation by writing x as 3 minus 2y, okay, all squared. 3 minus 2y all squared minus 4y squared is equal to -33. By squaring this binomial, you get 9 minus 2 times 3, 6 tends to 12y. Plus 4y squared minus 4y squared again is equal to -33. 4y squared minus itself is 0. So you have 9 minus 12y is equal to -33. So the -12y is equal to -33 minus 9. So the 12y is equal to, just multiply by -1 and add, 33 plus 9 is 42. So the y is 42 over 12, which is divided by 6, 7, divided by 6, 2. So the y equals 3.5. After knowing the y, you have to come back to the first equation and substitute in the first equation to find x. Okay, so the x is equal to 3 minus 2 times the value of y obtained here, 7 over 2. The answer is 3 minus 7, which is -4. So this is the value of x and this is the value of y. You can of course write it as 3.5 or 3.5. Question number 3, given the simultaneous equation, that these two equations show that 5y squared plus 3y minus 80, this equation is in the variable y, so I have to remove x. The variable you want to remove, just to make it subject, okay? So make x subject from the first equation by writing x, this equation number 1, x is equal to 2y plus 1. As you see here, just I add 2y to each side. And after that, go to the second equation and substitute with the value of x in the second equation. So just to start by writing 3y times, we do not write x now, we just write 2y plus 1, which is the value of x from the first equation. Continue writing the second equation, minus y squared is equal to 8. Okay, so remove the bracket by multiplying 3y inside, so 6y squared plus 3y minus y squared minus 8 is equal to 0. Arrange your equation, will be 5y squared plus 3y minus 8 is equal to 0. Just factor. 5y squared is 5y times y. The 8 maybe is, I want a difference at 3. Already the difference between 8 and 5 is 3. So just write 8 here and 1 here. And make it 8 positive and 1 is negative because 8 is negative value. Now the middle term with 3y is the correct factorization. So you have two values of y, really. Y is negative 8 over 5, or maybe the y is equal to 1. By substituting in the first equation to find the corresponding value of 2y's, again, the y is negative 8 over 5, the first one, or the y is 1. So by using the first equation again to find the x, the corresponding value of x for the y negative 8 over 5 is 2 into negative 8 over 5, okay, plus 1. And by using a calculator, you can find the value of x in simplest form, negative 16 over 5 plus 5 over 5, which is negative 11 over 5. Okay. The other one, the x here is, the y is 1. So if you put 1 here, it's easy to know that 2 times 1 plus 1 is equal to 3. So the x here is 3. So the order pair 3 and 1. In the second point, the first point is negative 11 over 5. And the corresponding value about negative 8 over 5. Negative 8 over 5. These are the 2 points of intersection of the curves represented by these two equations. Okay, I hope everything is clear. Question number 4. By eliminating y from the equation, if you want to eliminate y, you can simply make y subject from the first equation as I told you. So y is equal to 2 minus x. Substitute in the other equation, this equation number 1. Equation number 2 will be x squared plus x times the value of y, which is 2 minus x, minus y squared. The y is 2 minus x again, squared, is equal to negative 1. By solving this, you'll get x squared plus 2x minus x squared minus the bracket of 4 minus 4x plus x squared, which is squaring of 2 minus x, or 2 minus x times itself, plus 1 is equal to 0. Just I bring negative 1 here on the other side. Now x squared minus x squared 0. I have now, if you start by writing 2x, okay, minus 4 plus 4x minus x squared plus 1 is equal to 0. And arrange the equation by writing the leading term first, negative x squared plus 6x minus 3 is equal to 0. Multiplied by negative 1 to get x squared minus 6x plus 3 is equal to 0. This equation you cannot factorize. Look at this one. Show that x squared equals x squared minus 6x plus 3. This equation I want to show. Yeah, is it the same equation we get or not? Yes, the same equation. X squared minus 6x plus 3 is equal to 0. And after that, hence or otherwise, solve the simultaneous equation x plus y is equal to 2, and x squared plus xy minus y squared is equal to negative 1. Yes, you can solve this equation by complete square or by any other method, by quadratic formula. This equation can be solved like this. X minus, you take half of 6 minus 3 all squared minus 9. These this part the same, this part the same first two terms, plus 3 is equal to 0. Okay, so x minus 3 all squared is equal to, this is negative 9 plus 3, negative 6, make it 6 on the other side. So x minus 3 is really positive or negative root 6 by taking the square root of each side. Just take a square root here and square root here. So the x is 3 plus or minus root 6. This is the value of x. Okay? You can substitute in the first equation. Don't forget the first equation, y is equal to 2 minus x. Substitute to find the corresponding value of y. So just split this value of x. Okay? So x equals 3 plus radical 6, or x equals 3 minus radical 6. And come to the first equation, as I told you, y equals 2 minus x here. Y equals 2 minus this x. It means minus 3 minus radical 6. The minus will be distributed over the two terms. So, sorry, 2 minus 3 is negative 1. So negative 1 minus radical 6. Okay, this is the first part, first value of y. And the other value is 2 minus this. When you subtract this expression, you just write it minus 3 plus radical 6. So the answer is negative 1 plus root 6. So this is the answer, really. This is the x and the corresponding value of y, and this is the other x and the corresponding value of y. Okay, the answer here is real number, not irrational numbers, of course. Question number 5, I have exponential equation 3 to the x is equal to y to the 9 to the y minus 1. Show that this. To show that here, that x is 2y minus 2, so simply just factor 9. You just write 3 to the x is equal to, the 9, as you know, is 3 squared. Yes? Raised to the y minus 1, and according to the index rules, you just multiply the inner power by the outer one by writing 2y minus 2. Multiply the 2 by y minus 1. The first left-hand side is the same, 3 to the x. Now, since, or we can just write it here, since 3 is equal to 3, therefore the x is equal to 2y minus 2. This equation is only exists, or is correct only when the bases are equal, so the powers must be equal, as you see. Okay? Solve the simultaneous equation, this one. After showing the first part, how can you solve the simultaneous equation, this one? You can substitute, as I told you, from the first into the second. Always substitute from the linear equation into quadratic equation. Okay? So just instead of x in the second equation, just write 2y minus 2 all squared, okay, is equal to y squared plus 7. And after that, 4y squared minus this and this, and there's 8y plus 4 minus y squared minus 7 is equal to 0, just to bring this side here with it. So 3y squared, 4y squared minus y squared minus 8y. Okay, 4 minus 7 is negative 3 is equal to 0. By factorizing this expression by 3y squared is 3y times y, the negative 3 is also can be 1 times 3. Make it negative 3 times positive 1 to get a difference, negative 8. Now, the middle term, as you see, is 1y minus 9y gives you negative 8y. Yes, correct? Yes. So, the corresponding value of y here, y, of course, you can take 3y plus 1 is equal to 0, or y minus 3 is equal to 0. Consequently, so y is negative 1/3, negative 1/3. Just write it here. Y is equal to negative 1/3, or the y is 3. Always come back to the first equation, the linear equation, that tells us the x is 2y minus 2. So the x is 2y minus 2. I can substitute now. I know the values of y, negative 1/3. Just put it here. So 2 times negative 1/3 minus 2. It's a negative 2/3 minus 2. This 2 simply can 6 x and then 3 to be easy to subtract common denominator. And the other one, y, not y, I'm sorry. So x is equal to 2 times 3 minus 2 gives you 4. Okay? So I have 4 and 3. And the other pair is what is here? Negative 2, negative 8 over 3. Negative 8 over 3. So this pair is negative 8 over 3. And the y is negative 1/3. Okay? There's the answer. If we come to question number 6, solve the simultaneous equation by the same way. I'd like to leave this question for you as a practice. Please solve it as homework and leave your answer in comments. Okay? And we have the last question in this video, question number 7. The curve and the line given by the equation this and this now. These two equations, one is linear and one quadratic, but we have one of the coefficient is unknown, k, where k is non-zero number. Non-zero means it cannot be a zero, can be any positive or negative number, no problem. Intersect at a single point. These lines intersect at a single point like this. Consider this is a parabola, first equation, and the other equation line just intersect with the parabola at only one point, okay? And do you remember the quadratic equation has only one root when the discriminant, the delta b squared minus 4ac is equal to 0. We try to apply this rule. But first of all, find the value of k. How can I find the value of k here? We try to substitute from the first equation into the second equation as normal, from the linear to make y here. It's better here to make y subject from the second equation. Y is equal to 1 plus half k or k over 2x. Okay? We substitute from this equation into the first equation. Okay? Let's start. K x squared minus x into the y is 1 plus k over 2x. Okay? Plus k plus 1 into x. We leave x and only substitute for y. Be careful. A minus 1 is equal to 0. Is it okay now? Yes. Follow me. Kx squared minus x minus k over 2x squared plus, no problem. I can keep it because there's only terms of x. I can keep it. Okay, I can keep it. Okay, k plus 1. No need to multiply kx inside. Minus 1 is equal to 0. It was, yes, plus 1. So I have two terms of x squared just to add, or I can multiply all by 2. That's no problem. Kx squared minus half kx squared is only half kx squared. This and this together, half kx squared. The terms of x, look, k plus 1x and the minus x, when you add these together, the one with the negative 1 is cancelled, so you have only kx. Okay? Minus 1 is equal to 0. Multiplying the whole equation by 2, so kx squared plus 2kx minus 2 is equal to 0. As I told you, this equation is has only one solution or one intersection point between the two equations. It means the delta is 0. The b squared minus 4ac is equal to 0. So the b squared is 2k. Okay, 2k squared minus 4. The a is k. And the c is negative 2 is equal to 0. So I have 4k squared plus 8k is equal to 0. So divide the full by 4. So you have k squared plus 2k is equal to 0. By taking k common factor, k plus 2 is equal to 0. Now I have two solutions now. Maybe the k is 0, and this is rejected because k is non-zero factor. And maybe the other factor, this one, k plus 2 is equal to 0. Consequently, k is negative 2. So k is negative 2. Now I know the value of k. K is negative 2. This is the first part of the equation. Give the coordinate of the point of intersection of the line. So now come to the last equation I solved. This one, you know this one that I tried to get its the discriminant. Put k negative 2 here. This equation. You find x. So negative 2 x negative 2 x squared, and 2 times negative 2 here is negative 4x minus 2 is equal to 0. All equation divided by negative 2, you will get x squared plus 2 x plus 1 is equal to 0. This really complete square by writing x plus 1 all squared is equal to 0. So the x is negative 1. Okay, after knowing x is negative 1, you can find the y. The y from this equation, look at this one. Y is equal to 1 plus half kx. The y is equal to 1 plus half k. K is negative 2 already, and x is negative 1. So 1 plus, this is really 1. 1 plus 1 is 2. So the y is 2. The intersection point is negative 1 and 2. Thank you. That's it. Thank you for watching. Goodbye.